Oh, what's up? I'm Austin Griffith. I'm here with my friends Etta and Carlos, and today is day 2 of our Web 2 to Web 3 curriculum. We are in week 1, which is how to set up a wallet and become a power user in Ethereum. And today we're just going to set up a wallet. We're going to talk about mnemonics. We're going to talk about security. We're just going to talk about kind of getting you set up and an Etherscan, like disinterested third parties. We're going to tell you how to set up your wallet, how to be secure, and basically how to get started to become a power user in Ethereum. What's up, Etta and Carlos? How you guys feeling? You guys ready to do this?
Yes, let's go.
Yeah, excited.
Awesome. Okay, Etta, do you want to start by sharing your screen? I think the first place we should start is just dive into setting up a MetaMask. MetaMask is like the go-to browser extension. I think we should even start it off by saying that, disclaimer, like MetaMask is more worried about security than they are about user experience. So there's going to be some clunky things just in Web3 in general. There's going to be some clunky things. And so just know that like these guys are security first. They're thinking a lot about your security, and we'll talk through some of the differences and some of the interesting things. But here we are, metamask.io. Take us away, Etta. How are we doing?
Yeah, so basically just going to metamask.io, and then it's a Chrome extension. So a browser extension, you can just, well, you do have also like phone. You can install it to your iOS and Android as well, but we'll just install for Chrome for the time being. And then let's just get to it, just adding the extension.
And make sure it's like MetaMask, make sure you're on the official website. You're looking for very official things here. Make sure you don't get phished and someone sends you to metamask.com or something. There we go. So we've added the extension. You pinned it so it shows up. It's got the nice little fox, like 3D animation thing. This is a security feature. This fox is a security feature. It's something that, impersonators would have a hard time creating, probably in 2016, probably not anymore. I don't know. We'll have to ask Dan Finlay about that. Wonder if it's still a security feature. It probably is. Okay, here we go. Let's get started. Okay, this is the scary part, right? What the heck? No, I already have a secret recovery phrase, or I don't. And by secret recovery phrase, they're talking about that 12-word seed phrase, right? We should probably create our own at first, right? Let's not import one.
Yeah.
But let's really talk through this 12-word seed phrase. Oh, they're going to really help us about this, aren't they? They're going to say never share it. Never share
So
anything.
it's pretty good with like, I think, explaining what to do.
Yep.
Like it also has the video. But since we're starting from scratch, just, it gives us all the warnings. But I think we can proceed, right?
Here we go. I agree. Okay, now the password. This is different. So we have a 12-word seed phrase, and this is the very, very critical thing. That is like, if you lose your 12-word seed phrase, everything is gone. This is just a local password. This password is used to encrypt your information locally. And so you'll need this password to like get into things. But if you lose this password, you can always destroy everything and bring back your 12-word seed phrase. And then at that initial like import box, you could import your 12-word seed phrase. So this is a much less secure, more ephemeral. You could probably just type in some, like, you shouldn't reuse passwords. Like, let's talk about security. You should have a password manager and you should use a good long password. But technically, this could probably be a pretty junky password. It's not that, because it's basically like, can someone that already has access to your machine open up your wallet, is what this password is setting up. So I don't know if you have a good password for us, Etta. Here we go.
I have
it's not
Etta
very
1,
long.
2, 3, 4, 5 for the point of this tutorial. But yeah, it's just going to be on the MetaMask. So like when logging in, but of course, like don't put like your name 1, 2, 3, 4, 5. But just since this is testing.
There we go. And we got some good like intro videos here, lots of stuff to watch. Things most people will probably skip immediately, but it's good. It's good. They're talking about the 12-word seed phrase being your master key, and we'll definitely like hammer that home today for sure. And password manager. Okay, here we go. The 12-word seed phrase. So this is the point where they've generated a 12-word seed phrase for you. And they've generated a really big the entropy here is huge, right? We've got a giant 12-word seed phrase. Now it's time for us to save it somewhere, right? So we need to reveal it, and never reveal it on a call,
Yeah.
never reveal it in front of each other, never reveal it on a shared screen like we have here. But for you, the user at home, that's what we're doing here. Here is our 12-word seed phrase: muscle, cram, fuel, winner, member, muffin, coin, jealous, fault, pool, auction, tired. There it is. Those 12-word
Looks
seed
like a
phrases.
hard one.
That is a good one. Yeah. Those 12-word seed phrases, those 12 words, basically in that order, is our master key. That's exactly the best way to say that. Like, those 12 words we can take these 12 words and we can write them down somewhere. We can save them somewhere. And if anybody gets them, they can recreate our entire wallet and they can empty the wallet, right? So yeah, let's paste it in there. So let's talk about some ways to save this, right? One method is to write down your 12 words on a piece of paper and store it in your sock drawer. And that's an okay way to do that. What else? What do you guys, what are some other methods of saving your 12-word seed phrase?
Yeah, I would store it in like 2 different sock wallets. Sock closets, sorry, not sock wallets. But I see a lot of people take screenshots, and that is something you should never, ever, ever do. Like, don't take screenshots or like send it to anyone from WhatsApp. That's just not a good way.
Never
like,
send
I
this
think
to anyone.
The only thing is password manager, or like I would write it myself. Like, even not do that. It's like your bank account information, and everyone can get it.
It's you said a password manager. That's another good kind of a good place to store this, like 1Pass or Keeper, or some of those password managers. You can just copy paste this into there as a giant password. And of course, like, this is, you're keeping, again, like, this shouldn't be millions of dollars. If you have millions of dollars like backing this 12-word seed phrase, it should not be in a Keypass. It should not be in your sock drawer. You should probably eventually have a smart contract wallet with many signers, a hardware wallet being one of those. And we can get into that more, but basically, places to store this. Let's say you stored it in your sock drawer, and that was the only place you stored it, and your house burned down. Your seed phrase would burn down also, right? And maybe your laptop is in your house and it burns down. Okay. And then all of a sudden, all that money is gone, right? So maybe you could keep it in your mom's sock drawer. And if her house burns down, then you restore it. If your house burns down, it's at her house and your laptop is dead, but you can go get your 12-word seed phrase out of her sock drawer. But if someone breaks into your mom's house and goes through her sock drawer and finds a 12-word seed phrase, your money is gone instantly. They're going to take your money very quickly. If you accidentally have it in a text field and you share it on GitHub, or anybody gets any whiff of this 12-word seed phrase, your money is gone immediately. So you want to store it somewhere where you can get to it and recover it in the case of an emergency. Is that a good way to explain that? Am I missing anything major here?
Like, some people, I think they get like maybe too creative. And then if you do like some tricky ways to store your seed phrase, maybe no one is going to store it from you, but maybe you won't be able to recover after. So don't get too crazy when storing the seed.
That's a really great point. Some people will set it up so I have the first 6 words at my mom's house and the last 6 words at my brother's house, and they need to come together to put those together. But like, there's no chance in hell that they're going to get that together and have everything and get that right. Or people who will like weld it onto a piece of metal and bury it in their backyard. So this is another good point, is to prove to yourself that you can recover it. And maybe we'll do that in a little bit, but having your 12-word seed phrase in your sock drawer is only half the battle. You need to then, if you kind of totally delete your account and you go grab that 12-word seed phrase, can you recover your account from that 12-word seed phrase? And that's a great point, Carlos. It's like some people will get super creative about it, and then like there's no chance that people are going to actually go through this process to figure this out. So it's less about being creative and it's more about being secure and finding one good, answer. Splitting it up is a great way to do it, but just make sure that how you split it up is very clear, and the people who have the 2 pieces or 4 pieces have very clear instructions on how to put those together to get back to the 12-word seed phrase to recover it.
Yeah,
okay, are we ready?
Good practice it would be to before like sending like real funds to your wallet, maybe try like deleting MetaMask and trying to set up like again, like before sending, and make sure that you can access your MetaMask with your seed phrase before like sending any.
We should probably even do that today. I think we should probably do that on the call to show how it works. But I say we get started. I think we've really like covered the 12-word seed phrase pretty well. Here we go. Let's continue on with the MetaMask installation. We've got our 12-word seed phrase backed up somewhere, just in our notepad for now. But you at home, perhaps you could write it down on a piece of paper and put it in a sock drawer. Perhaps you could put it in a key holder, like a password saver, or some kind of other intricate storage method. But here is our 12-word seed phrase. Here we go. Let's go ahead.
I just wanted to add one note. I also see a lot of people like say, I want to do this later, but I would recommend like doing it when you're setting it up. Like otherwise you can forget, log out, then you have no way getting back in. So like when you're setting it up, like make sure you have like half an hour to go through this process.
And maybe we'll cover at the end of the call some ways where there are methods of onboarding where you don't like just straight up start with the seed phrase. You use an account, and then eventually you'll bring that account into something else like a burner wallet. But we can save that for the end. Yes, on onboarding, you should probably just do this 12-word seed phrase. Okay, so here we go. We have to prove that we have our seed phrase, and we have to prove that we have it backed up by basically putting them in order. Is that right? So we're going through and we're restating our 12-word seed phrase.
I have one question, like why Eda is at it. Yeah. So what stopped me to create like a script with get like a list of all the words and start like testing all the different combinations, and like I get the seed phrase, 12-word seed phrase, and I just check the balance for that account. And what stopped me to do that, because I mean, it's only 12 words, right? It's not too many. So I can just like create a script that reads like a dictionary and start like testing like random like known words. And maybe at some point that we find, some accounts with balances. I don't know.
That's a great point. And that's one thing that we really need to hammer today. And it's kind of a strange thing that like, technically someone could guess your 12-word seed phrase, right? There's only so many words. I think there's like 5,000 words in this particular dictionary, and there's only so many combinations of those 5,000 words. But the thing that we'll discover today as we get into this is that there's so many that it would take so long. You could have everyone in the world running that script, and it would still take a million years to find someone else's account. And our human brains are pretty hard at like, it's hard for our human brains to even really grasp that. I think a good example is shuffling cards. When you shuffle a deck of cards, there's, what is that, like 52 factorial is the chances that exact shuffle has existed before. And there's all these decks of cards all over the world, and all these humans are shuffling them. But if you give it a good shuffle and you get a good randomness, no one else has ever had that stack of 52 cards in that exact configuration, which is like, our brains are not good at understanding that. Like, that's hard to grasp. And the fact that someone could just guess this, technically someone could just guess your 12-word seed phrase. Like, they could get these 12 words in this exact order, and all your money would be gone. But it's incredibly difficult and incredibly like statistically not going to happen. And we'll explore that a little bit more. Let's get into the numbers of it in a little while, but let's finish up the seed phrase here and let's get our account going. So what do we have? We have auction and then tired, and then we have
I just thought we could like do it wrong.
Oh, okay. Yeah, no, that's a great.
Like,
yeah, let's see what happens. We should do things wrong a couple. Oh, it just doesn't.
Doesn't even allow me to click confirm.
And then if you click auction entire, does it let you bring them back?
Oh,
Oh,
no.
wow. Lets you drag the order of them. Holy
Yeah.
Oh,
moly.
okay. So it doesn't allow you to confirm.
They do that, but I can't
correct.
even have optimism added to my MetaMask in startup, but they have that feature. You can drag and drop words in the seed phrase. That's pretty awesome.
Oh,
Okay.
yeah. And everyone.
Awesome. All right. So now can we confirm? Congratulations. You have set up an account on Ethereum. And what did it take to set up that account? This is another really weird thing. You don't have to get anybody's permission, right? When you're setting up a Wells Fargo account or you're setting up a bank account, you have to get all sorts of permission. And you are just an entry in their database. With Ethereum, anybody can participate. And all you have to do to create an account is to come up with a large random number. In this case, we have these 12-word seed phrases, and we'll show how that turns into a private key. We haven't even gotten to like the key pair yet, but basically anybody can create an account, and we'll show more about that in a little bit. But here is our account. Here's our MetaMask. We have 0 ETH in there, and it gives us an account, an address, right? Can we look at that address there? There it is. Maybe even, we could, paste that. I was thinking we could send, what should we do? Should we send some testnet ETH next to this address and send some things around? Do you want to maybe paste that into our shared chat?
Yeah.
And I will send some testnet ETH. So Ethereum is a public network anybody can access, but there's also these test nets, and these are for developers to use, and they're free. So they have a different consensus algorithms, and we'll get to all that, but they work just like public Ethereum. So just like you can send money on Ethereum, you can send money on these test networks, and these test networks allow us as developers to kind of tinker around and play with how Ethereum works and how to send things around without actually sending mainnet value. And that's more and more important as Ethereum is more expensive. Whoops, let me send. Okay, should I steal the screen? Let me steal the screen, and I'll show me sending from my MetaMask. Here we go. And I've got some other stuff here, and we'll cover some of this stuff later, but really what's important here is my MetaMask here. So I've selected the Kovan network, which is a test network, instead of mainnet Ethereum. And I'm going to hit send. I've got a whole bunch of Kovan, like $200 million worth of Kovan.
That's really hard to get.
That is. I've got some nerd connections. Yeah. So I'm going to paste your address in here. Okay. And when you're sending Ethereum, one of the first things you do is like kind of look at that 0x. I see 0x3c21. And then I kind of look over here and I see 3c21. And maybe even I look at the last few numbers too, FE673D. Yep, it matches up, right? So I'm kind of like at a glance, I'm trying to make sure I've pasted the right address. And as you use Ethereum, you'll copy and paste lots of addresses around. So you need to double, triple check before you send real money. Is this the right address? It looks like it is. Okay, I'm going to send 1 ETH of Kovan to your address, and we hit send. And it'll take about 5 seconds. Okay, it's going to ask us about gas. We'll talk about gas and everything later. You have to spend a little bit of your ETH to send ETH, which is an interesting thing, and we'll get into that soon. But there it goes. We've crafted a transaction with our MetaMask. We've set the transaction to say that you are the to address, I'm the from address, and the value is 1 ETH. And there it goes, it just sent. You can go ahead and share it on your side, and let's see if we have some Kovan ETH in your wallet. And also how to get ETH, right? That's a whole nother question. Oh yeah, you'll need to switch your network to Kovan. That's one thing too. Oh no, look at that. They let us drag and drop, but we have to manually add Kovan. Is that true?
No.
I thought it came with like actually a couple of networks. But
oh wait, show hide. There's a show hide. There was a show hide there. Show hide test networks. Oh, phew. Oh. Thank goodness.
Oh, okay. So we can open the test networks.
There we go. See, this is why we do this. We go through this slowly and we run into weird problems. So you at home don't feel like, what the heck is going on? Yeah. This is some weird stuff, and we got to go through it slowly.
Mm-hmm. So Austin, you were saying that, I mean, not everyone have a friend like you, which have like a lot of money in Kovan. So what can they do to get like some test ETH? Because if they want to, to do some testing or send some ETH over, what can they do to get some free ETH?
let's go to that other browser tab. Let's copy our address first.
Yeah.
So the 3C, let's copy our address, and then let's just Google search. Yeah, there we go. Let's search testnet, ETH, and faucet. The word that you're looking for there is faucet. Yep. And let's see, the Paradigm has a really good one even. Let's see, there's a Rinkeby faucet.
I like the
Faucet,
Rinkeby faucet as well.
Let's go to it. Let's use it. Yeah, it's purple. Let's click it.
Yeah,
Okay.
oops, it's offline, right?
Like,
Oh, no.
This happens sometimes that you try to get
Yeah.
Ethernet and no one works.
Yep. And that's going to happen. So these test networks are real networks where they have the full, proof of stake happening or proof of work happening. And so they're attackable by attacking those systems. And it's kind of like a Web2 network kind of hosting up in Web3. Ooh, different language. So you'll,
This is Turkish, but it gives us, it basically
you're
also
good.
tells you like the different facades which you can go to. Faucets, yeah.
The Paradigm one, that third one there, that's my favorite. Let's try
Yes.
that one and see what it lets us do.
Okay, so I guess we
you
need
might
to
have to
sign in
with
with Twitter.
I don't know if you have, Edit Tweets has signed in. At Edit
We're
Tweets, give her a
signed,
follow. And we paste in our address.
Yeah.
Drip on additional networks. What does that even mean? Like some weird EVM compatible networks, they'll send you some
maybe.
things. I like it. Okay.
Yeah, it says a couple.
So yeah, this is going to give us all sorts of stuff on all sorts of networks. Let's see if like maybe we have some Rinkeby. It'll take. So let's pull that up real quick. Let's talk about the test nets
nice.
just for a second. We've already got it. It worked. If we look at this just for a second, just the list of networks while we're talking about test networks. So Ropsten is a proof of work network, great network to test like user experience in terms of like the transaction is going to take a long damn time and your user interface needs to adjust to that. There's Kovan, which is the one we're on, which is good for quick transactions. A lot of DeFi protocols test things on Kovan. The next one I think is Rinkeby. Kovan has 5-second block time. Rinkeby has 15-second block times, but great for testing NFTs. OpenSea and everything is over on Rinkeby. And then the last one is Goerli. And Goerli is just like, that's where the cool kids hang out. That's probably where we see the merge happen and a lot of other things. So Goerli is probably the most like future proof of the test nets, maybe. IDK, I don't know, actually. This is like my view as a developer, but those are all the test nets. So we've got some testnet ETH. We're able to send it around. Maybe you could send me some Kovan, send some Kovan back to me, and then maybe we could use Etherscan, a disinterested third party, to kind of inspect these transactions and figure out what's going on. So yeah, let's try to send some.
Yeah, so I could get your address from here.
Yep. Yep.
But if you have anyone's address, you could just like copy paste it as well.
Yep.
So I'm adding it here. I'm gonna send you 1 ETH back, or let's send.
Perfect.
Yeah, let's send you one. I'm not keeping any Kovan.
And just like a little disclaimer, a little star, this account is completely like exposed, right? There's a 12-word seed phrase that we've already put up here. So all of this is like, this account should be like toxic, and we should understand that this is like toxic waste here. But it's a good thing to show you at home how to really go through this and how to really inspect it. Okay, Etherscan. Etherscan is a public good in Ethereum. Etherscan is like this really important infrastructure where you can go here, and it's called a block explorer. You can go here and you can explore all these different transactions and find out what's happening on chain. And this is Etherscan for mainnet, but really we want to go, and you can see, yeah, you can see the price of ETH, you can see the last block that was mined and each block after that. And the blocks are just full of transactions from people using Ethereum. But let's go to the Kovan one and let's make sure. So let's say you sent me some ETH and you want to like prove that you sent the ETH to me, right? Like, let's say I'm over here and I'm like, I don't see it in my wallet. And you're like, I sent it in my wallet. How do we know for sure? What do we inspect here?
I think the transaction, right? The transaction hash is what it says. I'm just kind of thinking out loud, but I feel like you can send this link and it shows like what process it is.
That's perfect. Yeah. So 7 seconds ago, or whenever 7 seconds ago when the page loaded, we can see that it went from 3C21 to 34AA, and I'm 34AA, and you're 3C. So we can see that the money
Yeah.
went. We see that there's a value of 1 ETH, and we see that we paid some tiny amount in a transaction fee. That will obviously be a lot bigger on mainnet, your transaction fees, because you're kind of, there's a whole economic system that's happening to make these things safe and secure, and you're paying for that. And the more busy the network, the more you'll pay. And we'll get into gas more, but there we go. What do we click to see more? What else do we see? We see gas limits and gas fees. We'll cover all of that stuff in a little bit. And there's even a little data field, and the data is empty. So everything on Ethereum is a transaction, even interacting with smart contracts and doing weird things. And we'll get to that eventually. That's where that data field comes in. But for you as a new user, you've got your wallet, you're able to send things, you're able to use Etherscan to kind of like double check those things. So here we go. We were able to send. Yeah, go ahead. I think let's see, what's next? What's the next thing? We're able to send value back and forth.
Maybe you must like click on the address, like on the front.
Yeah.
If you click into the address on Etherscan, like you can go like to your address on and see like all,
right? Yeah, if you click right there. Yep. Yes. There we go.
You see like all the transactions on your account.
Yep. So we saw the 1 Ether come in and the 1 Ether go out, right? But we don't see the money from the faucet because it's an internal transaction. If you click the internal transaction, we'll probably see there's another one. Yep. 4 minutes ago, 1 ETH came in from a smart contract. So some other account triggered a smart contract to release us 1 ETH, and that was that faucet that we used.
One thing I can add, I feel like this comes up, like it came up with me, is that you cannot revert the transaction. Like once it goes to, you can't be like, oh, I want it back, I did it by mistake. Once it's gone, it's gone. Like there's no like customer service which you can call to get it back.
Right, exactly. There's no customer service for Ethereum. It's basically,
yes,
if it's gone, it's gone. Now, this brings up some fun stuff about the mempool, right? I don't know if we want to get too far into the mempool, but there's the too long didn't read is you're paying a little bit of gas to make your transaction go through. And there's only so many transactions that can go through at once. So you're bidding on your space on chain, and the people who bid the highest get into the block and get their transaction through. So there's this like kind of economic system that happens where you're bidding to have that slot. And so the fees are going to be higher on mainnet. But there's something really interesting you can do here. And you're saying you can't cancel your transaction. Technically, you can submit another transaction to the mempool. While your first transaction is in the mempool but hasn't quite got mined yet, you can submit another transaction with the same nonce, but higher gas and like a higher bid, and have it send $0. So you can send a second transaction that sends no money and get it into the mempool quick enough and get it mined. And you can technically, if you do that quick enough, cancel your transaction by sending a second transaction. But as soon as that transaction is mined and we see it here on Etherscan, it's gone forever, and there's no help and there's no hope and there's no customer service. And that's a really hard part about Ethereum. And this is a big gotcha about using cryptocurrencies, is this no help support kind of thing, right? Once it's gone, it's gone.
Yeah. I think that's
awesome.
How the speed up works. Like, as you mentioned, like sometimes you can speed up your transaction, so pay more gas for it.
Exactly. You could have put it in. So right now, mainnet gas is about 60 gwei, and I think we paid 2 gwei here. But say you put it into mainnet at 30 gwei, and that it's telling you it could take 2 days for that to go through. You can submit a second transaction with all the same information but higher gas price, and you sign that, and it goes to Ethereum, and it'll go faster. Yep, exactly. Okay, so we're able to create a wallet. We're able to have our 12-word seed phrase, and we're able to save it. We're able to send Ether around. This is like, these are our baby steps, right? This is the first baby step. We've taken our first baby step into Ethereum. We're able to send things around. So possible things to explore next, and I think we should go through them here on the call, is what's happening here in terms of the seed phrase and the private key and the public address, right? We haven't really talked about ECDSA Keypairs yet, and I think we want to know how that 12-word seed phrase derives into a key pair and how that key pair is signing things. And I'll steal the screen for a second, but let me just open it up to you guys and say, like, you know, where are we here, and should we jump into the 12-word seed phrase? What do you guys think?
Yeah, I mean, I think so. Also, like talking about like generating like more, because with one seed phrase, you can generate like multiple accounts, right?
Yep.
Multiple addresses. So we haven't talked
Let's
about that yet. Because we only have like one seed phrase and one account for now. But with one seed phrase, you can generate the same accounts over and over, right? So yeah,
let's do it.
If you want, like you can create.
Let's make a new account and send like half of our ETH to it. Yep. So now you're creating a second account, which is a second address within your MetaMask, within your 12-word seed phrase. Like Carlos said, you can have a 12-word seed phrase, but then there's this indexing system. So you, out of one 12-word seed phrase, you can actually have like infinite accounts. And MetaMask is going to help you keep track of all those accounts that come from that one seed phrase. Let's send some ETH from account 1 to account 2 and double check it on Etherscan.
Yes, and these accounts are going to be always the same. That's the important thing.
Yes.
It's like the deterministic, right? When you have the same seed phrase is going to generate like the same accounts over and over again. So if you delete MetaMask, like all your accounts are going to disappear, I think, and it's going to show like only number 1. But if you click like new account, it's going to generate like the same in the same order that you had it before.
And no one knows that how those accounts are connected, right?
Yes.
It's basically a hash. It's a one-directional function. So if you send some money from one of your MetaMask accounts, it's not like everyone knows that now these other MetaMask accounts are also related to you. No one can figure that out and derive that. So yeah, let's send it. Oh, that's me though. You're sending it to me. We want to send it to, I think I'm 3AA. This is user stuff from Ethereum. Like that 3AA is me, right? Yep. You want to go to your second account and copy it, and then go to your first account and send it. Yep.
Okay, so I accidentally clicked this, but you could directly transfer between my accounts. Clicking like
they just have that built in. Okay. Yeah.
I didn't know that. That's good.
Yeah, I didn't know that either.
I always do it like that because I always mix.
It's safer. To know that like this is definitely going to one of my other accounts rather than like copy my other account address and paste it in. Cool little secret there. There we go. Sending 0.5 ETH from one account to the other account. And like Carlos said, all of your accounts will always be there and it'll be deterministic. So this account 2 that we've created here, if we destroyed everything and brought our 12-word seed phrase back, account 1 would be there and we'd have to go new account. And when we created that new account, deterministically, that second account will be there and it will be the same. It won't have the name, right? If you named account 1 Alice and account 2 Bob, and then you trashed everything and you brought it back, it's just going to be called account 2 again, right? You're not going to have Bob there or anything. So as you name these accounts, understand that naming along with that password is all like kind of just local. It's not something that's going to be stored anywhere or tracked. Okay, so we created a second account and we sent in some ETH to it. Can we double check on Etherscan? Like, can we copy that new address and put that new address into Etherscan and just go look and make sure that everything is correct and MetaMask isn't lying to us or something? There we go. There's the transfer from one to the other. We see the value. We see a tiny transaction fee. Again, this third party, disinterested third party. Etherscan doesn't give a crap about your accounts, right? But it's a great place to go to double check that everything is working the way you think it is. You can always send stuff from the wallet and the wallet looks nice, but always go over to Etherscan and double check things and make sure things are working right and someone's not, messing with you.
I think on this point, we could also like lock the account just to see like what our local passwords are doing, like the one we created.
Yep.
And it's always like best practice to like lock your MetaMask account, I think. So do lock it.
And it locks pretty quick. Like after 15 minutes of inactivity, that'll be locked also. And one thing we haven't talked about here is like this thing is a Chrome extension. Like, why is this a Chrome extension? Why do I have a wallet that's a Chrome extension? And the answer to that is this wallet's going to unlock the ability to interact with decentralized apps. And these apps will be websites. So the cool thing about having this wallet as a Chrome extension is it's going to allow you to use your wallet to talk to all of these decentralized apps by just connecting in your wallet, and you never will give these apps anything secret. The apps will let you use them, and then they'll bubble up a transaction to you, and your wallet will sign that transaction in its own little enclave and then send just the signed transaction back. So none of your private information goes to the dApp, and the dApp basically has you sign things and send things back. dApp is such a word, such a decentralized app. I feel like I need to just say decentralized app, because dApp is such a hard word to say. Okay. So would you mind sending the 12-word seed phrase to me in Telegram? Don't do this at home. Don't do this at home.
Don't do this.
Never send your 12-word seed phrase. If someone asks you for your 12-word seed phrase, you should run in the other direction. Okay. So I'm going to go ahead.
Like bots just take like if you post to GitHub, like by example, I think they're like automatic bots, which will just take it in like 5 minutes.
Yes, exactly. It's gone. Maybe we should do that.
Yeah.
I wonder if we should send a little bit of real ETH to this account, and then let's like put the 12-word seed phrase on GitHub and see how long it takes.
Yes,
that would be kind of a fun thing.
That would be interesting.
I think it will take like 1 minute.
It won't take long. No, it won't take long. Okay. So I want to dive in. And just talk about, since we do have like, hopefully a lot of developers are watching this. They understand Web2, they understand how to program, but they don't exactly know kind of what's going on here. These are called ECDSA key pairs, right? Ooh, ECDSA verse, I saw it in there, ECDSA verse RSA. I think I saw it there. That would be a good, there is a good little like side quest to go on. But oh great, thank you for the pop-up. Yes. But the concept is ECDSA. It's this elliptic curve cryptography. I'm not going to go too far into it because I will sound like an idiot because I don't know what I'm talking about. This is like, cryptography, and it has this really cool curve and this really cool property, but I am not smart enough to explain how the curve works. What I can explain is kind of like how we think about it in terms of a tool in the toolbox, right? So basically an ECDSA key pair consists of a private key and an address. And this is kind of one step away from the mnemonic, which we've already seen is kind of like this 12-word seed phrase. So I'll show how these things are connected in a little bit, but I want to focus just on a key pair. Is that big enough? Can we see it okay?
Yeah.
Yeah. Okay. So this is, even though like we were talking about how that 12-word seed phrase is like the thing, this is actually like the thing. The 12-word seed phrase is used to produce this right here. This 64 character, these, you don't need the 0x, but these 64 characters of hex data, this is your private key. This is the thing that is going to sign these transactions. This is the thing from the curve. This is your secret right here. This thing right here basically derives this address. So, and let's go ahead and just like generate a few just to show this happening here. Oh, get out of there. Let's just go ahead and just generate a few, right? I can just keep clicking, and all this is doing is generating a giant random number. Like assume this is just hexadecimal data, and that can actually be turned into a number, and it's just a huge number, right? So we're talking 2 to the power of 256. Oh, why can't I do to the power of? Oh, darn it. Dang. Okay, let's ask Google 2 to the power of 256. 2 to the power of 256, right? This is going to be a huge number. 7E77. Okay, so a huge number, right? So so basically, to create an account on Ethereum, to be able to interact with things, you create a number between 1 and this, right? You just come up with a random number. And that's all you need to do to participate. We generate some random number, okay? Boom, there we are. There's our giant random number. And from that is derived this address. And like Carlos, like you were saying earlier, well, can't someone guess this? Can't someone guess your seed phrase? True, they could. They could guess this exact seed phrase, but there's so much entropy here. There's so many in the space of 1 to 2 to the 256. There's so many possible that they could spend a lifetime generating accounts and checking the balance and never find something. And in fact, all the humans on Earth could spend a lifetime generating random numbers and checking to see if there's a balance on Ethereum, and they'll never find anything statistically. But there is this chance, yes, someone could just magically come up with this, but that's the statistical likelihood of someone guessing your private key is so far impossible that, like, understand that it's a possibility, but it's impossible. The heat death of the universe kind of stuff, right? It's a long ways away. Okay, so we've got our private key. We understand this thing is the magic, and this thing is the thing that signs transactions. Whenever you want to send a transaction, that transaction needs to be signed by a private key. And that's, notice there's no from address here. That's what we derive when we say who the from address is. That's derived from whatever that private key is that signed this transaction. Okay, so that key pair can be used to sign and recover, or sign transactions. And let's just play with that real quick. If I drop a private key in here and we have a message, Austin sends 5 to Edda, okay? And that's what we want to sign, and we go ahead and sign that, okay? And what comes out of that is the message and the signature. Now, this message will probably, imagine it looking more like an object, right? With to and from, and can I just pull an object out of here? There we go. Yeah, there we go. Imagine it more like this, right? But let's just think of it like a message. You can also sign messages, but think of it like this, you know, to Alice from Bob with a value. That's the kind of message we're signing here, right? Austin sends 5 to Edda, and then this signature goes across the network. And what's interesting here is, like, this can go across a public network. Anybody can send and receive this information. And if anybody tinkers with it, if anybody changes it, then it's not going to work. It's going to fall apart and it's not going to work. But on the other side, if we try to recover this, we use the ECDSA key pair and we use the recover function, we should get back that same address. Okay. And if anything changes, let's just change this. Let's bring this in here and bring this to here, and we get the same thing, but let's disconnect this. Austin sends, let's say Edda gets in here and edits this to 6. Oh no, our address changed, right? So now it says Austin sends 6 to Edda, but it's not Austin's address that signed it, so it's not valid, right? But if you have this signature and Austin sends 5 to Edda, sure enough, it does recover to Austin's address, so we know for sure that Austin is sending that. So this is like the magic of these key pairs, is you can just generate a number to create an account, and then you can use that number, and don't share it with anyone. You can use that number to sign a message, and then that message can go across a network, and anyone else can use ECDSA math to recover who it was that signed that message. So really in the weeds here with how this works, but just assume that, like, this really cool key pair is just a giant number that's used to sign these transactions, and we use that to keep track of who has what and who has sent things. Anything to fill in there? I want to bring in mnemonics here, but like I kind of went off the deep end here with private keys. How are we doing? Is this covered correctly?
I had a mini question.
Yeah.
So I was wondering, like, that text, the signature, is that the transaction hash which we were looking at? Or
a transaction hash, like, no, a transaction hash would look a little different. So if we create a transaction with our private key to we're sending it to ourselves for some reason. I don't think I need to put anything else in here. Let me see if I can just sign that. That will create a transaction hash, and basically the hash is like all of this information hashed. Right? Let's see. Okay. I don't think this is going to work. Nope. What if I just like stringify it? This is not how it works, but let's see. Can I do this and then do this and then do this? Yeah, something like that. That's possibly, that's basically how the transaction hash works, but probably not the way I just did it. I don't know. That's probably not going to be the transaction hash, but that's basically where that transaction hash comes from. It's the hash of the whole thing with the signature. Yeah, eventually there'll be a signature here, and then this signature would also be in here, And that's where the transaction hash comes from.
Okay, so that's like a message which I sign with my private key. Like it's
yes, exactly. This would be the transaction details. Austin wants to send $5 to Etta with the nonce of 4, and nonce, we can get into nonce a little bit, but it's probably not like same thing with gas. Like we don't need to really mess with it. Nonce is just like for replay protection. If I send 5 to Etta and I put that across the network, then Etta could just broadcast this information over and over again. And if we didn't have some kind of replay protection, then you could have Austin sending 5 to Etta every minute for the rest of time, right? So what you need is Austin sends 5 to Etta, number 1. And so only this one will only be played once, and then number 2 has to happen, and then number 3 has to happen. That's how this nonce works, but we don't want to dive too far into those details yet. Okay, so basically, let's clear that. How do I get that out of there? Oh yeah, there we go. Okay, so going back to this, you can create an address on Ethereum by just generating a big number, but this is hard to keep track of, right? Like even if we were going to write this down on a piece of paper, that would be a huge undertaking. I don't want to write that thing down on a piece of paper and then have to recover it, right? So what they came up with is, knowing that we need to get to this hash, could we come up with a system that's easier for humans to save and store things and recover things? And this is only one account. Could we do it where we have, one thing we store that's easy for a human to replicate, that could have a number of different accounts? And so that's this mnemonic system that we have here. We have this, let's see, mnemonic 12-word dictionary. We have this dictionary of words. Let's see if we can find it. Got some Scooby-Doo there. Where is that?
Like BIP 39, right?
Yeah, like 39, isn't it? Is that right? There's a 59 word list. There we go.
39, yeah.
Yep, there we go. Here is the English word list. So there's only 2,048, interestingly enough, right? So we only have 2,048 different words. And what was that? 2,048 12 fact, and 12 words. The combination of those is a huge amount, even though it seems like, wait a minute, that's like, there's a smaller, in terms of like how many private keys you could generate, in terms of how many combinations of 12-word seed phrases, your human mind says, well, I can just take 12 of these random words and just keep jamming on it and find someone's seeds phrase. And your brain thinks that, but trust me, it's really, really hard. Oh, here we go. You go ahead and say that out. What was it? Carlos, I think you just posted something to chat about how hard.
Oh, yeah. I was like, I took this from a Reddit comment. Like someone was asking like the same question that I was asking, like, can just like someone like guess my 12 seed phrase? And he did like the math, they did the math, and it was like brute forcing a 12-word secret phrase from a 2048 word list. Each guess has a 1 in 2048 up to the, how do you say, like up to the 12, right?
To the power of 12, yeah, I think.
Power of 12, yeah. And it has like 0 point, and like insane amount of zeros, like 184% chance of being correct, which is like, and it says, if you could make 1 trillion guesses per second on each of 1 trillion computers, it will take the lifetime of the universe so far to have a decent shot at it. So yeah, I like.
That's so cool.
Yeah, so it's like
let me put that quote in here. Yeah. Oh, you can't really read it though. If you had 1 trillion guesses per second on 1 trillion computers, zoom, 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 zoom. If you could make 1 trillion guesses per second on 1 trillion computers, it would take the lifetime of the universe so far to have a decent shot at it. Yeah, that's a good way to. It's still so hard for our brains to even comprehend. I feel like, but still, like it's possible that someone can just come up with sister baby sentence essence above embark airport walk put tobacco excite humble. It seems like that's a very approachable thing to a human to come up with, but it's actually like very, 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 very hard in terms of like statistical probability. It'll never happen, right? Okay, so we have this 12-word seed phrase, And we know that if we generate a good 12-word seed phrase, it's almost as good as generating a giant random number, but it's a lot more approachable. And so what we're going to do is we're going to take this 12-word seed phrase. Okay, let me just get like a text box and put that in there. Okay. And then we're going to use a hash function. Nerds out there know what a hash function is. One directional, deterministic, hash function. There we go. So look at that. If we take the hash of this, and let's see, if I change tourist to Jimmy, watch over here, and this changes, right? So if I put tourist back in there, tourist, right? See how with each keystroke that is changing, right? And it's not changing close. Like if tourist with a T or tourist with an F, they're not close at all, right? It's not like you can get close by trying things. It's picking a random number out of the whole set, and it's all over the place. There's not a way to get close, right? So we have our 12-word seed phrase, and we hash it, and we get a private key. This actually works. Like we could take this private key box, and we could plug this in as our private key, and that's going to give us an address. And we could change this to, let's change it back to Jimmy, right? Jimmy is going to be this account, but tourist is going to be that account. And we're going to get the same thing every time. Back to Jimmy, back to tourist, right? So it's this deterministic way of taking these 12 words and turning them into this private key. And so now the last thing we would add to this is some kind of index system, right? So we have tourist 1 will be that account, tourist 2 will be that account, tourist 3 will be that account. And so this isn't the exact format, but this is how this system works. We come up with a 12-word seed phrase, and then we add an indexing system, and that lets us create as many accounts as we want from that one seed phrase. Okay, so now we can kind of just plug this private key in here, and we can just create an index system. Okay, now what I want to do is I want to copy your 12-word seed phrase that you sent me here. Again, never be sharing these things around, never be copy pasting these things. Very bad idea. In GMI, here we go. I'm going to paste it into here as some text. There it is. That is our seed phrase, right? Muscle, cram, fuel, winner. Okay. And then if we do index 0, here is the address that comes out of it. There's your private key, and there's the address, and hopefully 3C, hopefully this is the one that we've been looking at on Etherscan. Uh-oh, nope, it's not. What did I do wrong here?
Is that mainnet?
Oh yeah, that was mainnet. Good call. See, this is why.
So maybe you can also click on the B on the top, right? So there you can show how. Yeah.
Wait, what was I going to click on here?
Yeah, I was saying that on Etherscan, if you go like next to your address, you have like a B. You see like a B
right here.
Yeah. Yes. So if you look at that, you see like
neat.
Yeah.
Sure.
Like
I didn't know this.
Yeah, I didn't know that either. B. This looks like an ad to me. When I see this, I was like, "This is someone paid to have this here."
Yeah.
My brain just like totally ignores that.
So it just said like the number of.
Yeah.
Now we know. Carlos clicks the B. All right.
Yeah.
Covan. There we go. So here is your address though, right? We were able to put in your 12-word seed phrase and index it with number 0 and get your account out of there. Ooh, okay, here we go. Now let's do blockchain, and let's bring in some chains here. I don't know. Let's see if I just do chain. Nope, that's not what I want. It's been forever since I've used this. Oh man, chain, boop, boop. There we go. That's what we want. Instead of mainnet Ethereum, let's go to Covan. Okay, it'll be a different endpoint. Okay, and now let's look at the balance of this homie right here. And I'm just going to put that on a timer. And there it is. Okay, and from Way, okay, this is another thing that we're going to have to get into is the difference between ETH and Way. But technically, if you were to ask the blockchain for your balance, it's going to give us this big number, right? And that goes all the way back to the EVM needs to be super simple, and it needs to be decentralized. So it's not going to have floating point math. Too long, didn't read. You have this giant number as your balance, but what you do is you divide that by 10 to the 18. We basically assume that there are 18 decimals here, And that's what this box is doing. And it's telling us that we actually have 0.49 ether. And if you want just a side quest, we have lots of side quests here. Ether versus Whey. If you look at ether versus Whey, you're going to find some good explanations and some nice tables that explain kind of how to do that. Like we measure our gas in Gwei, and the smallest amount is Whey, and butyrene, really? And ether is there. I bet he didn't name that himself. Okay, there we go. So we were able to find the balance of this dude. Now, the other thing I want to do is look at the next account, right? Let's look at account 1 here. And it actually has it's 460. This is the second account in your MetaMask, right? When you added a second account and we sent 0.5 ETH to it. So if we were to go 2 here and you were to share your screen again and add a new account, it's going to be that address. And your 42nd account is going to be that address, right? And if you had 5,000 accounts in your MetaMask, the 5,000th account would be that one. And that's all deterministic using basically a mnemonic and an index. Yeah.
That's great. Yeah.
Yeah. So there it is. Now, okay, let's build a bot that looks for seed phrases. Okay. And if it finds a seed phrase, it sends the money to us, right? So let's pull our seed phrase out. Let's get rid of that one. Let's generate a new seed phrase. Okay. And let's just leave it on. Okay. And then the balance is 0, right? And look at this. We can just generate it and it's going to go check. Let's actually trigger. Here we go. I'm going to put a delay in. And I'm going to take, look at this weird stuff we're doing here. And I'm going to go doop, doop. So then after we generate, it waits a second and then checks the balance of it. Okay, we have our bot, right? Basically,
let's wait. Yeah.
Let's wait. Okay, let's sit here on record until I find some money, right? Okay, and let's do mainnet, right? We're looking for real money, right?
Yeah.
Okay. And every single developer, and if you're a developer out there and you're not at least a little bit curious about this, you're crazy, because every single developer says, well, wait a minute, it's only 12 words. I can hash that. I can find a private key. I can get the keys to everything by just guessing them. And you think you can, but trust me. and don't trust me, trust the math. Go do the math, figure out how many different possibilities, how many different 12-word seed phrases there are, and figure out how long it would take you to just do this process. Wouldn't it be hilarious if I just found one just now and it had money on it and it just made us all look silly? But trust me, no one has done that. No one has done that. And I'll tell you why. We can go look at any of these accounts. We go look at the 0 account or something like that. There's a $100 billion bounty that says that you can't break this, right? And so there's a lot, even though it's possible, there's a whole lot of things in place and a lot of systems. If you could break this, you could break RSA and SSL and steal people's credit cards. This is just not, you're just not going to find something here. And you can try, you should, as a programmer, you should just build a little script that does this just to prove it to yourself, put it on an AWS box, spin up 100 of them, have them work for a week. You're never going to find anything, right? Okay, now here's where you can find some stuff. If we were to put in our own mnemonic and we were to say something like, whoa, what's happening here? Oh, I don't want to generate. Oh boy, I'm not sure what's going on here. Let's hello world. There we go. Okay, so using the mnemonic hello world, I actually can generate an account from that, right? And if we go look at that account on Etherscan, I'd be willing to bet some transactions have happened. Nope, no one has ever used hello world. Okay. How about, I know someone has used the word love, right? The word love at index 0. Come on, give me some transactions out here. Someone has no, what? Okay, maybe I'm doing something wrong. Let's see here. Is it generating? It is generating an account. That's a private key. Okay, so short mnemonics though, you can create an address. I must be doing something wrong because I know that this, I've looked up a couple of these and found people. What about just hello or something? These are very insecure addresses. I don't know why. I know there have been transactions on these. I don't know if I'm doing something wrong. I wonder if it's not allowing, I square. Let's go see. How would we see transaction address? Yeah, we would see it on Etherscan. I don't know why. Maybe we should send, okay, should we send a little money to here and see what happens? It should get like drained immediately, right? That was the other thing, is if we posted our 12-word seed phrase into GitHub, how long it would take. I bet we could find out how long it would take if we wanted to see that. What, let's see, anything else we need to cover today? Like, let's check our topics here. Ooh, custodial versus non-custodial, right? Go ahead, Etta.
Yeah, I was just gonna ask, like, for me it was confusing, like there's a seed phrase, then there's also the private key. Like the most important thing is like your mnemonic, your seed phrase, like that's like one way, you can't go the other way around.
Exactly, like from the mnemonic is derived the private key, and from the private key is derived the public address. Yep. But like your private key and your mnemonic are just as sensitive. Like don't share either one of those things, right? If you share your private key, basically that one account is hosed. If you share your whole mnemonic, all the accounts under that are hosed. So yeah, either way, both the private key and the mnemonic are very, very sensitive. But the MetaMask like password, not as sensitive, right? That's just on your machine. Okay, go ahead, sorry.
Oh, I was just gonna say, like, especially like when you're doing like applications, you usually add your private key. So that's not the seed phrase, but it is as important to get that and like keep it safe. So don't also push that to GitHub.
Right, exactly. You're saying like when you build an application, you'll import the private key to sign some transactions. But if you ever go use an application, if you ever go online and you're like at a DEX and you're trading things and it says paste in your private key, don't do that. Never put in your private key anywhere, except for that one spot in that one MetaMask when you're doing an import that one time when you're recovering your account. That's the only time you should ever be moving that mnemonic or private key around. Cool.
Yeah, exactly. Cool. I meant like on your own Visual Studio Code, like nowhere else, like not
and even else. When you're doing that, let's say that you have an account with money in it. Like we've generated these two MetaMask accounts. When you're talking about putting in an account to go do something, a script, maybe you have a script that's going to send 1 ETH every month to some savings account or something like that. Don't use your private key. Go generate a new one. Knowing that it's so easy to create a new account, you should be creating new accounts for every new thing. So if you have a new script that you're going to run, don't copy paste your private key from MetaMask into that script and use it directly. Generate a new private key. And it's really easy to generate a private key. Like there's a ton of little tools that'll do it. ETH build will do it. You can do it by just putting in 64 random characters. You as a human are not good at that in terms of putting in randomness. But if you're writing a script, have the script generate a new mnemonic, have the script generate a new private key, have the script generate a new address, send from your good address to that address a small amount of money. And if that happens to get pawned in GitHub or something like that, you're not going to lose everything. You're just going to lose that deployer account's address. Does that make sense? Okay, yeah, custodial versus non-custodial. Yeah, go ahead. No, you go.
Yeah, like I don't think anyone should ever use their like a real wallet for testing. Like don't use that for like building test applications.
Yeah. Yep. I do all the time and it's a terrible practice and I'm gonna get hosed one of these days. But I use like AustinGriffith.eth. Someone so like there's lots of builders building like DEXs and multi-sigs and token vendors through the speedrun Ethereum. And I'm always clicking into those and flipping to Rinkeby and making transactions with my main wallet. And that is very, very bad practice because one of those days, one of those things that someone sends me is going to be a mainnet transaction to send them all my money. And I'm going to go boop, 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 boop. And then I'm going to go, oh, what did I just do? And it'll be gone. And that I will look like a fool, but don't do that. Use just like we set up a new MetaMask. It's really easy to set up a new MetaMask, set up a dev MetaMask and have it in a different browser and use that for your development stuff. Cool. Okay, we should get to custodial versus non-custodial, right? There are ways where you can hold Ethereum and you can not be in control of these private keys. And a lot of people will do that to start off. Something like Coinbase, where you can hook up your bank account to Coinbase and get Ethereum. You can move your money to Ethereum, but there's this saying about not your keys, not your coins, right? Yeah, and so in this case, what's happening is there is Ethereum there, but Coinbase owns the Keypairs, and they have a little entry in their database that says Carlos has $5, right? And so they have $1 million over here in this one account, and they have Carlos has $5 in their database. And if something goes wrong and that database gets overwritten, someone messes with it, someone tinkers with it, someone changes it to $2, there's nothing Carlos can do about it, right? Carlos can say, hey, I had $5 yesterday, now I have $2. And they just say, you know, not gonna make it. Like, that's sorry, bro, we changed it in our database, right? And so if you own your own key pair, no one, it's yours, right? No one can ever guess it. No one can ever take it from you. It's your key pair. And if you lose it, you're completely hosed. So there is like this kind of like responsibility that you have around owning your own key pairs. And at first it's fine. Put $100 in Coinbase, put $100 in some centralized exchange, just so you like understand how things flow. But in terms of keeping your own money, once you're confident and you understand this mnemonic and how these private keys are generated and how to take care of them and be secure, then that's where you want to kind of have your ETH, is in your own custody. You need to custody your own keys, but not until you're ready and you're safe. And by the way, like, even putting your money there is probably not the best way. There's better ways to store it. And we'll get to like contract wallets and hardware wallets. I mean, we'll get to we should probably just talk about those now. Maybe we should get into that. But am I hammering this home good enough with the custodial versus non-custodial stuff?
Yeah, I mean, like, one counterpoint into that is like Eda said before, like there is like no customer support of MetaMask.
There's
so
no customer
support.
So
if you lose like your seed phrase, like, you are done. I mean, you don't have your funds anymore, because I mean, if you put like your money in a centralized exchange like Coinbase or Binance or whatever, of course it's not your keys, so not your coins, but they are centralized, which means that if you lose your password or something like that, and I bet that you can, you know, like tell them, you know, like, I lost my password, and they will like verify like your identity again or whatever, and they will recover your account. But, you know, if you have like your own keys, if that happens, you can't call anyone, you know, MetaMask or a friend, no, can you recover my funds that I lost? No, sorry. So you have like to be like super conscious about that, you know, about the security of your keys, because you are like 100% responsible of your keys and your coins and your wallet. So just like be careful about that.
Basically a database, right? A custodial solution has your account in their database, and a non-custodial solution is stored on chain, and it's using key pairs, and it's using ECDSA math, right? And so if they lose it, something goes wrong. Mt. Gox, if you want to look up, Mt. Gox is a famous centralized exchange that had everyone's, basically a couple key pairs and everyone's accounts in databases, and someone hacked it. Someone got those main key pairs and took all the money. And so that was it, right? Yeah. So if you had your money on that centralized exchange, it's gone, and you can go to customer support and be like, my money's gone, and they will be like, everyone's money's gone and we're hosed. Like, we're moving we're moving to Mars because we don't want to be in charge of this anymore. So there's also this like existential risk that their security can get hacked and everyone's money can get lost. So that's another kind of thing with custodial accounts, but it's fine if you're just getting started. If you're not quite confident enough yet in your own abilities to take care of that 12-word seed phrase, it's okay to have a couple $100 in a custodial solution just to get you started and just to get you understanding like kind of how to go. So
one more question, like, how can you get like money into your MetaMask account? If you don't want to use like a centralized exchange, is there a way to get like money directly to your MetaMask?
What's really cool is you can earn ETH, right? You could go do a bounty on Gitcoin and you can earn ETH. You can go you can make some art and upload it to OpenSea and earn ETH. So there's a lot of like utility to using ETH and earning ETH just directly. Like, you can earn currency to an address that's never had some. But let's talk about ramping. I think what you're alluding to is, how do I get money from my fiat bank account, cash in my hand? So first of all, there's an ATM machine at the gas station that takes cash and gives me back Bitcoin and Ethereum. So there's like these all around, right? So you could technically just like use one of these stations super weird, but like that's pretty awesome that that's like out there. But I would say a lot of good places to get started, not only with how do I get ETH, but how do I get a wallet. Ethereum.org has great resources for that. And let's see if we can find it in here. Let's see, use Ethereum wallets, and get ETH, second thing there. Okay, so how to buy ETH. There's going to be a bunch of centralized and decentralized exchanges. And basically you put in fiat, you put in some amount of USD or some currency, and you get back the currency. But again, all that's happening there, this is a custodial solution. You're saying, I would like to put some money from my bank account into Coinbase and I would like to get some Ethereum. All that's happening there is they're making some changes in their database. They're saying, okay, he doesn't have this USD anymore, but he has now this Ethereum, and it's just a change in a database. Until you get out to the decentralized exchanges where you're actually exchanging tokens for ETH or the opposite. So two things here, and we haven't really explored the wallet space very much. We should probably explore the wallet space a little bit. Basically, all we've talked about is MetaMask, and there are so many other cool wallets. So take some time to explore all the wallets, but yeah, so MetaMask is just one of them. And another favorite, man, there are too many wallets to choose from. And I've told my buddy Sam about this. He needs to trim this down a little bit. But the other one that I want to look at is Rainbow. And this is just a beautiful wallet on mobile. You have this really kind of great experience. It's going to be the same thing though. When you go to set up a Rainbow, you'll put an app on your phone and it's going to give you a 12-word seed phrase. And you'll do the same thing with that 12-word seed phrase. Put in a sock bar, put in a password manager, do something creative with it. But make sure that you can destroy it and bring it all back again, and make sure your accounts exist again. Like, prove to yourself you can recover it. But it's going to be the same process in all of these wallets. Probably a little smoother in Rainbow than some because they do focus on user experience. But you'll download an app, you'll generate a 12-word seed phrase, and then you will have this this awesome mobile wallet. Same thing with kind of, I don't know if we can just like pick a random wallet here. So get a Coinbase wallet is another one. You can probably have a wallet coming out. This is leading us to something I've been alluding to a little bit, is smart contract wallets. So I'm kind of on the fence about hardware wallets. We should probably talk about hardware wallets real quick. A hardware wallet is like this little, I probably have some laying around here somewhere. It's like this little device. There we go. You have this little device, and on that device lives your private key mnemonic, and the device holds it, and it should never leave the device. Like your private key and a 12-word seed phrase, whatever is on that device, will just stay there and never leave. But you'll send transactions to it. You'll type in a little code, and then it will sign the transaction and send it back to your machine. You can use air-gapped things. There's all sorts of like crazy secure things you can get into, but just know that like hardware wallets are an available thing. The user experience is just not that great with a hardware wallet. You'll hook it up and it's just kind of a pain in the butt to make transactions. It's good to have a nice cold wallet that's a hardware wallet that you can go to if you need to bring in some funds. But if you're making like 20 transactions a day or 100 transactions a day, like I am, like, you don't want to use a hardware wallet for all of those transactions. But safety, like where, okay, so knowing that no matter what wallet we choose here, there's still this existential risk of this 12-word seed phrase either leaking or getting lost and all of our money being gone forever. How do we cure this like existential threat? And the answer is smart contract wallets, or the current answer, right? The best fix to this user experience is we're getting into Ethereum, we're learning smart contracts. We'll learn a lot more about this later, but you can deploy a smart contract, and that contract has an address, and that contract is your wallet. And what happens is there's rules built into that contract that say, if you want to send money out of this wallet, you need to have 2 out of 3 signatures from 2 out of 3 accounts, or 3 out of 5, or 5 out of 7, or 5 out of 11, right? What you can do is create a multi-sig where it takes many different accounts to coordinate together to send that money. And the two leading smart contract wallets are the Gnosis Safe and an Argent. And an Argent is more like, this is my wallet on my phone, and the recovery method is through these things called guardians, where I could set Carlos as a guardian, and then if I drop my wallet in the toilet, that's actually happened. I've actually lost my Argent wallet before because I destroyed a phone. And what I did was I got on there with one of my guardian accounts. I think even Argent will be one of your guardians. And I said, please recover. And it's not like a guardian can't steal your money. It's programmed into the smart contract that no one can steal your money, but what they can do is reset it and have it sent to a new wallet. And that's what I did. I regenerated a new wallet. I had it reset. There's like this grace period where the time period had to elapse. And once all of that happens, then it's written into the smart contract to be able to recover it to a new account without anybody stealing it. So that's kind of like this help for this existential threat of, man, this seed phrase is scary. Keep your seed phrase, but have a couple of accounts with a couple of seed phrases in a couple of different places, and have those on a smart contract wallet. So your life savings is not on this 12-word seed phrase. It's actually in, a diverse portfolio that contains some Ethereum, and in that Ethereum is stored in a smart contract wallet or somewhere safe where you can recover it. If you lose, one of those mnemonics, you can go to the other ones and you can recover it. Am I explaining all that correct? Alpha Wallet's another fun one. What am I missing here? What holes have I left in this explanation?
It's kind of like a multi-factor authentication for your wallet, I
Yep.
feel like, when you have like a second signer or second process.
And that's what it feels like a lot of times when I have my multi-sig. I have one account on my phone and one account on my desktop, and I have a 2 of 3 to send out scholarships from the Build Guild. When I go to send to someone, I'm like, I orchestrate the send on my desktop, and I get it all the way ready to send, and then I need that second signature. Then I pop in with my phone and I make that second signature and I send it. It feels exactly like 2FA. Yeah, it's very similar. Yeah. Okay, so you've got lots of wallets here to discover on ethereum.org. In fact, you have too many wallets to discover, but there are wallets out there. And then getting ETH, right? Getting ETH comes down to finding an on-ramp. There's tons of, let's just search for Ethereum on-ramp. What's gonna happen? Who's got the best SEO in the space? Ramp.network does. Congratulations, Ramp.network. You will be featured in our Web2 to Web3 curriculum. So what do we want to buy? We want to buy some ETH. Okay, let's go. There we go. And I'm going to put in some USD. And it's probably going to like bring up a credit card transaction here. I don't want to go any farther, but this is basically what's going to happen. You will ramp some of your funds in using some other method. I wouldn't recommend using a credit card. Goodness gracious. The price of Ethereum is all over the place. Don't max out a credit card or something. Like, let this come, like basically what I use is Coinbase, and I use Coinbase from my bank account. And then from my Coinbase, I send it into a multi-sig wallet that I have a signer on, my brother has a signer, my wife has a signer. Like that's like, it's very distributed. And if I die, they can recover it. If I lose my wallet, we can get together and we can recover it. So that's the combination of these two things that I would use, right? You use some kind of fiat on-ramp that's custodial, but you just go through that and you end up at a non-custodial solution. And the best place to end up is one that is like a multi-sig, that it's like a smart contract wallet that's more secure.
Yeah, but also like if you are like starting out, like it's okay to have like MetaMask with $100 and you don't need to worry about multi-sig or anything, because maybe it's like too much for people that are starting out, so you're fine with using like MetaMask at first.
Totally. I'm over indexing on the multi-sig only because I wanted to like share that this existential threat of this 12-word seed phrase getting lost is kind of scary. Don't worry, there are better solutions, but you're right. Just have a MetaMask and just start with a Coinbase, like straight up, like my buddies that are just learning about Ethereum. It's like, they're like, I want to stake ETH and I want to, use DeFi. And it's like, first get a wallet and have money on the wallet and be able to send money around. And that's what we did today, and use Etherscan to verify it, right? Like don't worry about all this like super heavy security stuff at first. Just get $100 in there and figure out how to send it around. And I think our next video will explore like how to use this wallet. Now that you have a wallet and you have ETH, we'll explore what we can use that for and how to interact with some apps. But just get a wallet and send ETH around and have a couple of accounts and have that 12-word seed phrase and prove to yourself you can recover your wallet from your 12-word seed phrase, and just like be able to send it around and get started. And don't be afraid of, all this other existential stuff. Just get it and use it and send it around. We're just trying to be a power user here.
And to add, like I started like that as well. Like I just like my account on a centralized exchange like Coinbase, and then I wanted to buy an NFT, which you couldn't do there. So that's kind of how I set up my first MetaMask. And as you saw, like it was 10-minute procedure.
Awesome. Yep, exactly. And we went through it, and we've exposed this 12-word seed phrase that we probably need to destroy. I'm checking the notes. Do we have anything else? The idea that in Ethereum, hopefully that it resonates with folks, that the idea of creating an account is just generating a large random number. Like, thanks to ECDSA Keypairs, this is a permissionless process. Anyone can create as many accounts as they want. You can sit there for the rest of time creating accounts as fast as you want. Like, that's fine. The system works, and that's how this works. So don't be afraid to create an account. Go out there, create a MetaMask, get a rainbow on your phone, explore some of the other wallets, figure out how to send ETH back and forth. If you don't want to pay the transaction fees of mainnet ETH, go to a testnet, grab some testnet funds, send those around. Just understand what it's like to custody your own keys, understand the process of sending money to and from a wallet, understand how accounts work and stuff like that. Understand how to protect your 12-word seed phrase. Understand that technically someone could brute force it, but they won't in our lifetimes. That's another, I bet some nerds out there are going to say, what about quantum
yeah.
math? Yeah. And it's like, not anytime soon. And as those new things come out, they will be built into these systems. And there will be a new, I also not a gigabrain. I am not a genius. I do not know how this is actually going to play out, but we have these systems of coming to a consensus. And as quantum math improves, these systems will also improve to include those things and become quantum resistant. I don't know what that actually means. That's fun putting these quotes around.
Neither do I.
I think we did it though. I think we created a wallet. We sent around ETH. We showed Etherscan and how you can, go to a disinterested third party. Hopefully you at home are not afraid of setting up your MetaMask. Hopefully you can go do that now. Is it metamask.io? What's the ethereum.org? Yeah, ethereum.org is the place to start, and you could go to these other places. Also, ethereum.org is hard to spell. Yeah, metamask.io, metamask.io, and watch out for MetaMask. If you type MetaMask into Twitter, you're going to get hit with a bunch of bots that are going to pretend like they're MetaMask support, and eventually they're going to ask you for your seed phrase or your private key. Never share that stuff with anyone. Don't do like we did on this call. We just wanted to show you. Never expose that information to anyone. That needs to stay private. Good job, everyone. Go create your wallets. Go get some ETH. Go get some testnet ETH. I don't know. Anything else? Any closing thoughts on creating a wallet?
I think it's time to start. Yeah.
Go get it. You out there watching this, go create your first wallet and get some ETH in it, either from a testnet, create another wallet, send it around, back that seed phrase up, then destroy everything and recover from that seed phrase and make sure you get your account with your money. And if you can do that, you're ready to get started becoming an Ethereum power user. And that's what we're here for. Awesome. All right. See you guys next time. Thank you for doing this.
Thank you.